Yeah.
Good morning. We are a group innovator, and today we will be presenting about a library room booking system through synchronization using semaphore. Our group member consists of Chong Jun Hong, Chua Jun Yi, Nasmi Haikabin Karu, and Li Shen Ying. So to start, uh, the topic that we get for this project is synchronization using semaphore. It's a most widely used algorithm to tackle synchronization problem. Through using it, user exclusion and process synchronization, it can allow the mechanism to access shared resources with multiple processes or threads without conflicting or interfering with each other. The real-world application that we decide to tackle with this topic is a library booking system. It is because the application of semaphore on the system allow it to control the availability of the library room in order to avoid overlap and lockout booking of room that has already been booked. Next. So the problem here is that the library often faces a problem of conflicting schedule. This leads to students often have to argue with each other to determine which get priority over using the room and has to leave disappointed or frustrated. This problem arises due to lack of mutual exclusion. So our aim is to solve the problem creating a code to showcase the implementation semaphore algorithm in solving the problem at hand, avoiding conflicting booking of the library room. Our primary aim is by demonstrating application of semaphore, showcase that through proper usage of mutual exclusion, conflict can be resolved and ensure that no conflict will occur. Next. So the objective here is explain the scenario that will occur in our project, draw the flowchart detailing the flow of our system, write a code that utilizes semaphore algorithm, explain the concept and principle behind the semaphore algorithm, showcase the semaphore algorithm code and explain how it works, and lastly, detail the benefit and potential challenges that the semaphore algorithm face. So the real world application are movie ticket booking system.
Okay, so my name is Chong Jun Ho. Now I'm going to present about the real application. So for the real application that implement the semaphore, so there's a movie ticket booking system, bus ticket booking system, and table reservation system. And our library booking system is also using the semaphore implementation. So now I'm going to talk about semaphore in operating system. So semaphore is a protocol mechanism for task communication, and is used to control access to share resources through mutual exclusion. And it's also used to signal the occurrence of an event and also allow two tasks to synchronize the activity. So for the implementation, so the semaphore, we use a variable s, which is an integer type. So when one process is modify the semaphore variable, no other process can modify the variable concurrently. This is the mutual exclusion. So the semaphore variable can only be accessed by two indivisible atomic operation, which is the wait operation and the signal operation. Okay. So for the wait operation, so this is the definition. So this while s is smaller than 0 is indicate that is busy in the critical section region or in a process in the critical section. So if it is not busy, so the semaphore will be decremented by 1. So for the signal operation, so the semaphore will be incremented by 1. Okay, so after that, the type, I will explain about the types of semaphore. There's two types of semaphore, which is the counting semaphore and the binary semaphore. So the counting semaphore is the integer value of the semaphore can range over an unrestricted domain, which is can be any number. And the binary semaphore is the semaphore where the integer value can only range between 0 and 1. For our project, the type of semaphore we use is the counting semaphore. Okay, so there are two types of implementation of semaphore. First is with busy waiting. So with busy waiting, there's no two process can execute the wait and signal operation on the same semaphore at the same time, which is the mutual exclusion, and the wait and signal code are placed in critical sections. So the another implementations of semaphore is no busy waiting. So each semaphore is associated with respective waiting queue. So each entry in the waiting queue contain an integers and a pointer to next record in the list. So it's implement two operations which are the block and wake up operation. So for the block operation is place the process that invoking the operation on appropriate waiting queue. And for the wake up operation is remove one of the processes in the waiting queue and place it in the ready queue. So that's all from me.
Good morning, Doctor. I'm Chawsuni. Now I would like to present about the design and implementation part. In our project, we have designed to do coding for a library room booking system that uses semaphore synchronization. So this is the system flowchart for our program. Next. Firstly, semaphore class is defined to implement synchronization operation for resource management. So the semaphore class has an attribute count of integer type, a constructor, wrap method, signal method, and get count method. The wrap method implements busy waiting when count is less than or equal to 0 and count is decremented. The signal method is used to increment the count. The other details of program will be implemented in the main functions. For the first part, it is program setup and initializations. This program displays the title, description, and use of the program. The total number of rooms available is fixed at 3, while total number of students is fixed at 6. A semaphore object is created and initialized with size of total number of rooms available. 3 arrays are created and initialized representing student state, duration, and number assigned respectively. Simulation start pass, the time variable of integer type represents current time slot. The complete variable of integer type representing the number of students completing their study in the room. The simulation start by entering the while loop until all students complete their study in book room. The time variable is incremented at the end of while loop. Moreover, a student state handling loop is defined. If student is in waiting state, and room is available, the room will be booked and the state will change to using. Else, the student will have to wait. If the student is using the room, his duration will be decremented, and if the duration is less than or equal to 0, then the state will change to completed. Else, it will display that the student is still using the room. If the student have completed their study, it will show he or she has completed using the room. So at the end of the simulations, the number of computer students using the room and total time unit used for all students to complete using the library room are displayed.
So then we move on to the result and discussion of our project. So first, I want to talk about the interface and the execution. So there are five key executions of our project. First is initializations. Initialization is when we initialize semaphore with a count representing number of available room and set up student states. Second is the booking request. Room is requested, semaphore ensures the request is fulfilled only when room is available. Thirdly is room usage. State of room is changed to using if a student use the room. And fourth is completion. Completion is when student state is changed to completed after study is completed. And finally, termination. Simulation ends when all students complete their room usage. So what is the output analysis? We have four output analysis, which is the efficient resource allocation. This means that there is no overlapping books because we don't want two students to use the same room at the same time. And then we have fair access. Fair access means that no student experience indefinite waiting. And thirdly is conflict prevention. This means that effective mutual exclusion is demonstrated. And lastly, is execution metrics. Our execution metrics is the average waiting time per student is 2 time units and the total completion time is 20 time units. Next. And now we go to the discussion. So in discussions, I want to talk about the key observations. First, we have the scalability. Scalability is when the system scales effectively with when room request and room availability changes. And then we have adaptability. The semaphore algorithm simplicity allows the adaptation to similar scenarios. And then we have reliability. The system guarantees conflict-free operations. So what is the challenges that we met while doing this project? We have the static room count and the limited scope. And next. Now I want to talk about the future work and conclusion. Our work, we want to implement dynamic room allocation. We aim to develop a number of available rooms based on peak hours or user demand. Second is real-time user interface. In future iterations, we plan to create a user-friendly interface where students can make real-time bookings or cancellations. Third is the IoT integration. By integrating IoT sensors, we could automatically detect room occupancy and update the system without manual input. Fourth is the advanced scheduling features. We would like to implement priority-based scheduling, for example, giving priority to urgent or group-based bookings. And lastly is the performance metrics. Integrating data analytics can help us track system efficiency, room usage trends, and improve the overall experience. So what is the conclusion of our project? The semaphore-based library room booking system successfully demonstrate the application of synchronization concepts to resolve real-world resource allocation challenges. By ensuring mutual exclusion and fair access, the system optimizes room usage and minimizes conflicts, providing an efficient solution for managing shared resources. Next. That is all from us. Thank you.